You can freely download this practical notebook from my website. From its home page, go to middle left and click Books and Notes. A new web page will open. Then download third book in PDF format. Experiment 12 in the practical notebook. Left side page of same experiment.
Today we will perform our new experiment. The name of the experiment is to determine the frequency of alternating current using Melde's apparatus. To determine the frequency of the alternating current, the apparatus which we need for this experimentation, it is known as Melde's apparatus. The main components which we will use in our experimentation, this is Melde's apparatus, this is known as electromagnet, this is a permanent magnet, it is an oscillator, it is a source of an alternating current, it is 220 volts. So now I am going to perform our experimentation to determine the frequency of the alternating current with the help of this Melde's apparatus. Step 1 is we will fix our this apparatus with the help of this G clamp like this one. Then we will check that this AC is coming or not. Because our objective is we want to determine the frequency of the alternating current using Melde's apparatus. So this apparatus is known as the Melde's apparatus. This is an electromagnet. This is a permanent magnet. It is a steel wire which is basically oscillating. The oscillation of this wire is, you know, that linked with the concept of the magnetization, because this electromagnet is attached with an alternating current which is basically obeying the sine wave. So because of that current, this steel wire will magnetize. This is a permanent magnet having two poles, north pole and south pole. Because the oscillation of the steel wire means the magnetization of the steel wire is linked with an oscillating current. So the oscillations of the steel having different polarity of the magnetizations will produce an oscillation. So step 1, that we will fix our apparatus with the help of the G clamp. Then we will check that main is coming or not. Okay dear students, now we are going to perform our experiment with the help of this Melde's apparatus. We will use a thread which is known as a string, and tie the one end of the thread with the one end of the steel rod, and we will take at least one or two approximately long thread, 1 meter, 2 meter, and this is the 3. The second end of this thread will be passed over this pulley. It is fixed on the stand, and the end of this thread will be attached with this hanger having weights. The mass of this hanger is 50 grams. So this is a way in which we are going to set our apparatus to calculate the frequency of the alternating current. Now we will check it's working. I am going to on the switch. Okay, my dear students, now we are performing our experiment, or we will take our observations after setting our apparatus like this one. Now we will switch on this button and observe the number of loops in this string. Either they are sharp or not. So we have two parameters by which you can control the sharpness of these loops, which are basically shows the standing wave. First is by change of the length of the string. By increasing or decreasing, you can make it sharp, keeping tension constant. The second way is when the length is remains constant, so with the increase of the tension in the string, you can also adjust the number of loops of the string like this one. So I am increasing the tension in the string to observe the effect of this tension on the number of loops. So you can see it, as I am increasing the tension in the string, the number of loops are decreasing. With further increase of tension, let me check it please. Yes. So you can see the difference between by increasing the tension when length remains constant, loops are decreasing, and the amplitude of oscillation that is increasing. So this is the increase of the amplitude of the oscillation. So this is known as standing wave. It is the first mode of oscillation because we are just observing one loop in the string. So now we will calculate the results, and for this purpose first we will measure the distance between these two knobs with the help of the meter rod, and the second one will measure the amount of the tension in the string with the help of the formula. The tension is the product of mass and the gravitational acceleration. So I switch off the button. Step 1 is with the help of this meter rod, I am measuring distance between these two nodes. So it is 97 point something, 0.5 centimeter. And what is the mass of the hangers? 50 plus 50 plus 50, because the mass of the each piece, you can see it is mentioned over here. It is written on each piece, that is 50 grams. So 50 plus 50, and the mass of this hanger is also 50. So 150 gram is the mass, total mass which we hand along this string. So now we are going to calculate our results. So we will use the table of observations and calculation. Okay, so after performance, now we are going to calculate our results. So we have some observations which are linked with the experiment. For example, the first one, the length of the string that was taken as 500 centimeters. Then we measured the mass of the string with the help of the digital string balance. It was 1.132 of grams. We need this small m. What is small m? The small m is the mass per unit length. So by dividing the mass of the string with the length of the string, the answer is 2.2 10 to the minus 3 grams per centimeter. So in our table of observation, our first observation means number of loops which formed during our experimentation, that was 4. Distance between the string nodes, that was 97.5 centimeter. Length of each loop was small m. It was equal to capital L over small p. What is capital L? It was the distance between the string node and the small p. That is the number of loop. The answer is 24.37. Total mass with hanger which we hand, that was 60 of gram. These are just most readings. Tensions that was measured in dynes. We are multiplying this 60 with 980. The answer is equal to 58860 per dyne. times. So this is a formula which we will use in our experimentation to calculate the frequency of the alternating current. So what is small f? Small f is the frequency that is equal to 1 over 2 times of L square root of T over M. T is the tension in the string, and what is small m is small m mean mass per unit. So by putting the values of the length of each loop, tension in the string and the mass per length, the answer that was posed that is equal to 104.71. So our second and third observation, you can increase the tension in the string or you can change the length of the string. So you will take 2-3 observations and then you will find out the mean frequency. Let us supposing that the mean frequency is equal to 103.1. For transverse mode of arrangement, because you can see there is a transverse wave, we want to calculate the frequency, so that is equal to 103.1 over 2, so the answer is 51.5. So you know that the correct value of the AC frequency, it is 50 Hz, so the percentage error, that is 3%. So this is a way and calculation with the help of Melde's apparatus. How can you calculate in your lab the approximate frequency of the alternating current? The other complete observations of this experiment is also present in your practical work. During your performance, we have some precautions to perform this experiment. The first thing is that the source voltage, it must be 220 volt. If the voltage or the frequency is no 220 volt or low voltage, either maybe you cannot see the oscillations of the string. Second one, this oscillator must be oscillating free. If it is not oscillating free like this one, you can see it. If it is not oscillating, so you can't measure the frequency of the oscillation, and that can produce a sources of the error. Similarly, while adjusting your apparatus, the ends of these loops, they must be sharp. This is basically a source of error. It must be sharp like this one. Another source of error is the sharpness of the nodes. Like this one, you can see it. I am just making 2 loops by the adjustment of the tension by my hand on the string. You can see that like this one. So these points, these nodes must be sharp. This is a wrong way. This is basically an error. This is a correct way. So while handling of the apparatus and by adjustment of the apparatus, you clearly cut shows the formation of nodes and the antinodes. And for precaution, the amplitude of the oscillations of these nodes while adjustment, they must be maximum like this. So these are some precautionary measurements during experimentation in order to measure the frequency of AC with the help of these Melde's apparatus. Thanks.
You can take this book from the store or free downloading from my website. These readings are given as a reference. Your readings may be different from these readings.